Hello everyone, welcome to 2021 Esri Developer Summit. In this presentation, we will learn about Esri's new capability for viewing non-vertical imagery called Oriented Imagery. My name is Kushagra Patel and I am the product manager for Oriented Imagery. In GIS world, we are well aware of terminologies like geotagged, which is an image with location of the camera. Georeference is an image with pixels mapped onto ground, and orthorectified means image is accurately georeferenced using a terrain surface. But what does oriented term stand for? Well, it's an image which has location, field of view, direction, and other camera parameters like roll and pitch. Quickly, what is oriented imagery? Oriented imagery is a capability that provides ArcGIS users, both in ArcGIS Pro and ArcGIS Online or Enterprise, the ability to quickly review street side, 360, drone, aerial, and terrestrial imagery captured by many different cameras. How does it work? Users picks a location in the map and finds the best available imagery for that location. What users can do with oriented imagery? If sufficient metadata exists, such as depth map, area and distance measurement can be taken from the imagery. Other features include digitizing features in image in ground space, labeling objects, and overlaying vectors on the imagery. Users can use their own source data or can license it from various partners or content providers. Key features of oriented imagery. It goes beyond traditional mapping imagery, mainly non-rectified imagery. It superimposes the maps into imagery and also imagery into maps. You can basically view assets from various directions for inspection purposes. It also integrates imagery with various 3D data like point clouds, mesh, etc. It is very lightweight and is designed to work in desktop, web, and mobile applications. You can create many solutions from it. Supports many types of image orientation like omega phi kappa or heading pitch roll. It is designed to cover three aspects of system of record. How do we manage the vast collection of data? How we integrate this data into applications, which is a system of engagement. And lastly, how do we extract information from these applications, which is system of insights. Who is it for? It is for anyone who manages physical infrastructure, wants to visualize, locate, inspect, or measure their assets. It is for various situational awareness applications as well. Below are some of the use cases like insurance inspection and property assessment, or maybe accessing ROV imagery for pipe interiors, or maybe viewing drone imagery in contacts. We will see these use cases in upcoming demos. Other use case like indoor asset management, where oriented imagery can be used to track static and dynamic assets within an organization and can support capital improvement spending decisions, or users can quickly find, use, or repair high value fixed assets across multiple floors and buildings. Let's look at the new capabilities that we have added in Oriented Imagery 2.6 release. Users can now filter images based on days, weeks, months, or years using Time Selector tool in the Oriented Imagery viewer. Users can now also add Oriented Imagery widget into custom applications created using Experience Builder. You can now visualize and exploit images on local disk in Oriented Imagery ArcGIS Pro add-in. So no need to upload images to cloud. We have introduced a new capability called Scene View, where images can be superimposed on top of 3D data layers like point cloud, mesh, and vector layers. We have added support for 360 video as well. You can now increase the size of the navigation tool to switch to different image. We have released a geospatial video image type to create oriented imagery catalogs from video log files. User interface has been updated for both widgets and sample apps. Okay, let's see all the capabilities of oriented imagery through this demo. For ArcGIS Pro, there is an add-in tool which can be used for visualizing images. I have two catalogs already added to the Contents tab. Select the catalog, turn on Coverage Map. Then select Data from Oriented Imagery tab. Click on Select OIC Location. Click in the green area to view the image. The red cross on map shows approximate position of the object in the image. As you zoom and pan in the image, the current coverage polygon updates dynamically on the map. You can adjust the brightness and contrast of image in the viewer. One way of navigating from image to another by clicking on camera locations in the image. Green means the image is looking in the same direction as the current image, and orange means it's looking in the different direction. Let's switch to another catalog. Turn on the coverage map to get the idea which parts of city are covered by images. Click on map to view image. As you can see, this is a 360 image. I can navigate from one image to another by clicking on green dots in the image. Let's switch to an 2D sample app. I will select San Bernardino first. Click on map to open the image. Now I can view this airplane from various directions using navigation tool. Click on blue dots to switch to that camera location. This is another way of navigating between images. Oriented imagery also has an automatic way of navigating from one image to another. This can be done by enabling the auto switch tool. In auto switch tool, while panning, when I hit the edge of the image in any direction, then the viewer switch to new image in that direction. You can see that the red cross is moving in the map. Let's switch to aerial dataset. Here the image source is an image service. You can also switch to different image by clicking on image thumbnails in the image gallery. Users can take measurements such as location, height above ground, distance, and area if depth map is available. Let's switch to a new dataset. Click on the map and the video will start playing where the location exists in the video. For various inspection workflows, users can digitize or create labels in the imagery. I have editable feature layer added to the map. I can add this to overlay tab in the viewer using the add button. Once added, I can now add features, delete features, or create labels in the image. I will create a bounding box around the fire hydrant in the image. As you can see, it dropped the approximate location of fire hydrant in the image. If I switch to other image, it will appear as a point rather than a bounding box. It will only appear as label in the image where it was created. I can also delete feature. Instead of adding labels, I can now just draw a point in the image. This is a 3D sample app. As you can see, there is a mesh layer added to the web scene. It's similar to 2D app. You can click a point in the scene and view the best available imagery. But here, instead of coverage polygons, you see coverage frustums, which get updated as you pan and zoom in the image. I can view the asset from different locations. Oriented imagery also have a mode where you can superimpose the image into the web scene on top of 3D data layers like mesh, point cloud, etc. Turn on the scene view and then click in the scene. As you can see, the image has been overlaid on top of the mesh layer in the scene. You can move the distance slider to move the image closer or farther away from the camera. This will enable you to see more or less of mesh layer. What typical oriented imagery workflow looks like. We just saw the visualization and exploitation part of the workflow, which is last stage as well. Users can view imagery, digitize, measure, and create labels. There is also another set of users which will use AI to analyze the data. Users can run deep learning tools and services provided by Esri to extract objects from the images. But to do this, we need to serve various type of data to these client tools in a uniform way, which can be done through oriented imagery catalogs. Now, these catalogs can be managed and published by GIS and imagery asset managers who can convert the source data to catalogs using oriented imagery management tools. Now, of course, the first step is data collection, where the organization can collect their own data or license, or maybe buy from various third-party content providers or partners. Let's take a look at the tools and how they are actually broken down. We have client tools, which you saw in previous demo, like ArcGIS Pro add-in. We have two sample apps. Now, these are just examples of how user can create these kinds of applications. We have Web App Builder widget. All client tools are extremely light in that all the work is actually done by Oriented Imagery API, such as reading the data, transformations, etc. API is driven off by Oriented Imagery catalogs, and we have tools in ArcGIS Pro at the moment which are used to generate these catalogs. Now let's see the Oriented Imagery workflow in action. We are going to create an Oriented Imagery catalog, and then we're going to inspect the Esri's new building E using the 2D sample app. Here I have a bunch of drone flights of Esri building E taken at different interval of times between 2018 and 2020. Currently, these files are on my local machine. Let's create an Oriented Imagery catalog using these images for inspection purpose. After downloading the Oriented Imagery management tools, add the GP tool to current project in Pro. The toolbox have a bunch of GP tools as you can see. First step is to create an empty Oriented Imagery catalog. Click on Create Oriented Imagery Catalog tool. Enter name, select Geodatabase, provide description. You can also provide attribution. Click on Run. Now the catalog is created. You can see that in the Contents tab, the catalog has been added as a group layer. Click on Add Images to Oriented Imagery Catalog tool. Select the catalog that we created. Since it is an image folder, input type here will be an folder. Select the image folder from the local disk. Imagery type would be drone/camera. Click on Run. Images are now added to the catalog. Let's zoom to layer and then open the attribute table of exposure points feature class for review. Now you can see the image paths are local. So let's copy the images to cloud so that we can access this data from web application. Click on Copy Images to Web tool. Select the catalog and the cloud storage where you want to store the data. After running this tool, the local paths will be automatically updated to point to web URLs in the feature class. Next step is to create coverage for each exposure point. Click on Create Coverage Features. Select from each exposure point and dissolve. Now we have the coverage graphic added to the map. Click on Create Coverage Map tool to convert it into layer package. You can change the properties of the catalog or set default values by using Properties tool. Let's analyze the catalog by running the Analyze tool. The last step is to publish the catalog on ArcGIS Online or portal using Publish tool. We have created and published an Oriented Imagery catalog. Let's visualize and exploit images in the 2D sample app. First, we will add the catalog we created to the widget using Add Catalog button. Turn on the coverage map to see the area covered by the images. Now click anywhere within the green area to view the image. As you can see on the top left side of the viewer, there is a time selector tool. It shows the latest imagery of the selected area. Let's travel back in time to see how much of work has been accomplished since 2018. Now let's view the east side of the building. You can increase the size of the navigation tool by clicking on the outer ring of the compass. I have set the date to 5th March 2020. Now, if I click again on the map, it will show me the best image taken on 5th March for that location. Let's talk more in depth about oriented imagery components that we saw in the previous demo. First component is Oriented Imagery API. As I mentioned in previous slides, Oriented Imagery API is the main component. It is simple to integrate into application. It is developed using JavaScript, WebGL, HTML5, and CSS3. The coverage polygons and frustums that you see in demo are also created by API. It does ground to image and image to ground transformations, provides feature collection interface. You can display images in web scene using the API. It also provides multiple view support. Next component is Oriented Imagery Catalog. What are these catalogs? It is an JSON structure, as you can see on the left side, which contains properties like name, description. It points to a feature service, which you can see on the right side, that contains all the image metadata like heading, pitch, role, field of views, cam, ori, and also link to images. Link of coverage map that we saw in the demo is also defined in this catalog. Since these catalogs are items in ArcGIS Online or Enterprise Portal, security can be handled at both catalog level and feature service level. Here we have various imagery types and sources that Oriented Imagery supports. So we support aerial, drone, 360, street view, and video imagery. Oriented Imagery can access both georeference imagery like an image service or imagery without georeferencing such as style handlers, feature service attachments, MRF file, JPEGs, or even non-georeference image service. Orientation is defined in feature service, and orientation is extracted from mosaic dataset, image services, frame table, or feature service attachments. If you have image folder or image list, then it is extracted from EXIF, maybe a table, or custom imagery types, which are just Python script. Using Oriented Imagery Management tool for ArcGIS Pro, you can create Oriented Imagery catalogs and add images to catalogs using various image types like frame table, image list, or image services. You can also create custom imagery types or create coverage maps. You can also copy images to cloud like an S3 bucket. You can create attachments or convert your images to MRF and then upload to cloud. Lastly, you can publish the catalog on your portal or ArcGIS Online. Lastly, we have visualization and exploitation tools. You can use the tools to view the images in the catalog, take measurements, digitize features, overlay vectors in image. In this client tools, we have Oriented Imagery Pro add-in, which is built on Chromium and Oriented Imagery API. Then we have, for the web environment, sample apps. The purpose of the sample apps is to quickly review and test OICs that you have created and published. We recommend users to create their own apps and add oriented imagery capability to those apps using the oriented imagery experience builder widget or the web app builder widget. And both the web app builder widgets and the experience builder widget along with the sample apps is again developed using oriented imagery API. In this demo, we will create another catalog and visualize it in custom web application developed using web app builder. Here I have set of images stored in a folder on my local machine. These images were taken using GoPro camera, which was mounted on my car. First, we'll create an empty oriented imagery catalog. Enter name, select geodatabase, provide description. You can also provide attribution. Click on run. Click on add images tool to add images to catalog. Select the catalog. Input type will be folder. Select terrestrial frame camera as imagery type and then click on run. Images are now added to the feature class. Let's zoom to layer and open the attribute table. Here you can see that chem heading for all images is -999. That means it does not exist. We can use the calculate heading tool to compute approximate heading of all the images. Provide minimum and maximum distance between two camera locations. Heading offset is offset in degrees between vehicle heading and camera heading. I will leave the parameter value as it is and click on run. As you can see, the chem heading values are updated in the attribute table. Now compute footprint of each exposure point. Once the footprint is created, convert it into a vector tile cache using Create Coverage Map tool. Publish the catalog, feature service, and vector tile cache layer using Publish Catalog tool. Select Add Images as Attachments and click on Run. Catalog is published to ArcGIS Online. Now that we have published our catalog, let's create a 3D app using Web App Builder. Select Oriented Imagery widget. In the configuration, add the catalog that we just created. Save the app and click on Launch. Select OIC from the list and turn on the coverage map. Select the location in the scene to view the image. You can find resources related to oriented imagery on Workflows page, which is the link at the top, and the download oriented imagery components from the links provided on this slide. Thank you, and please provide your feedback for this session by clicking on the link directly below the video.